Question number 102. If a 135 milliliter luminous tube contains 1.2 milligram neon and 1.2 milligram of argon, at what temperature will the total gas pressure be 13 millimeter of mercury? With the given data is mass of neon, which is 1.2 milligram, we know that 10 milli is equals to 10 raised to the power minus 3. So the mass will become 1.2 into 10 raised to the power minus 3 gram. Molar mass of neon is 20 gram per mole. So we can find the moles of neon. Moles of neon are mass over molar mass, where mass is 1.2 into 10 raised to the power minus 3 gram. And molar mass is 20 gram per mole. Gram is cut with the gram. And then moles come upside and it becomes the unit of the mole. When we solve this value, we get the ounce 1.2 exponent minus 3 divided by 20, and the ounce is 6 into 10 to the power minus 5. The mass of argon is 1.2 milligram, which is equals to 1.2 into 10 to the power minus 3 gram. Molar mass of argon is 39.95 gram per mole. Moles is equals to mass over molar mass. Here we put the mass of the argon, which is 1.2 into 10 to the power minus 3 gram, and molar mass is 39.95 gram per mole. Gram is cut with the gram, and we are left with the unit moles. So we can calculate the value of the moles of the argons, which are 1.2 exponent minus 3 divided by 39.95. So the moles become 3 into 10 to the power minus 5 moles. Volume, which is 135 milliliter. We know that 1 milliliter is equals to 10 to the power minus 3. So volume becomes 135 into 10 to the power minus 3 liter. Total pressure is 13 millimeter of mercury. We know that 1 atm is equals to 760 millimeter of mercury. So we convert the pressure into the atm. So we divided the 13 millimeter by 760. Here 13 is divided by 760. So the pressure is 0.017 atm. Because millimeter of mercury is cut with the millimeter of mercury, we are left with the unit atm. The formula for the product of air, the equation is used. Total pressure is equals to the moles of the nitrogen into moles of the argon, and the universal gas constant temperature divided by the V. Here we want the temperature, so all this quantity are go on the other hand side of the equations. So temperature is equals to the total pressure into volume divided by the universal gas constant and the sum of the moles of nitrogen and argon. The universal gas constant that we use is 0.0821 atm liter per mole per Kelvin. When we put the R values into this equation, be it total pressure 0.017 atm, volume is 135 into 10 to the power minus 3 liter. Universal gas constant is 0.0821 atm liter per mole per Kelvin. And the moles are 6 into 10 to the power minus 5 plus 3 into 10 to the power minus 5 moles, TK. So liter is cut with the liter per mole with the mole. ATM will go left with the 1 unit, which is the Kelvin. Now we calculate the value 0.017 into 135 into 10 raised to the power minus 3, which is then divided by 0.0821 and then divided by 6 into 10 raised to the minus 5 plus 3 exponent minus 5, and the answer is 310.59. We can write as 310 Kelvin, or maybe as 310.59 Kelvin. So the temperature will be 310.59 Kelvin. Thank and Jazakallah for listening. Bismillahirrahmanirrahim. Assalamu alaikum. Today we do physical chemistry numericals from chapter number 1, gases. Here we use the Dalton's law pressure formula. To question number 100, part number A, a typical 100-watt light bulb contain nitrogen and argon. If argon and nitrogen are added to light bulb to yield a partial pressure of argon, which is 98.5 kilopascal, and nitrogen, which is 10.9 kilopascal. What is the total pressure? The given data is partial pressure of argon, which is 98.5 kilopascal, and partial pressure of nitrogen, which is 10.9 kilopascal. We know the formula that the total pressure is always equal to the partial pressure of the all gases, okay? Then the total pressure is equals to partial pressure of argon plus partial pressure of nitrogen. When we put the values into this equation, then total pressure is equals to 98.5 kilopascal plus 10.9 kilopascal. Simply we add both of these quantities to find the total pressure. 98.5 plus 10.9, and the total pressure is 109.4 kilopascal, which is the total pressure of both these gases in the light bulb. Part D. If a 125 milliliter light bulb contains 5.99 into 10 to the power minus 4 moles of nitrogen and 5.39 into 10 to the power minus 4 moles of argon, what is the total pressure in kilopascal at operating temperature of 119 centigrade? The volume is given, which is 125 milliliter. We know that 1 milliliter is equals to 10 to the power minus 3 liter. So the volume will become 125 into 10 to the power minus 3 liter. Moles of argon and nitrogen, which are given 5.99 into 10 to the power minus 4 moles. And moles of the argon, which are 5.39 into 10 to the power minus 4 moles. Total pressure, which is unknown quantity, we know that the total pressure is always equal to the sum of the moles into universal gas constant, temperature, and volume. Here, the formula will become total pressure is equals to sum of the moles of nitrogen and argon, and then multiply the universal gas constant, temperature, and volume. We put the all values into this equation where moles of nitrogen are 5.99 into 10 to the power minus 4 plus 5.39 into 10 to the power minus 4 moles of the argon. Universal gas constant is 0.0821 atm liter per mole per Kelvin, and temperature is 392 Kelvin. Volume is 125 into 10 to the power minus 3 liter. Liter is cut with the liter per mole with the mole per Kelvin with Kelvin. We are left with the one unit, which is atm. Now we do the calculations, which are the 5.99 into 10 to the power minus 4 plus 5.39 into 10 to the power minus 4, which are equal to 1.138 into 10 to the power minus 3. Then multiply with 0.0821 and then multiply with 392. Which is 0.036624, then divided by 125 exponent minus 3. The answer will be 0.2929, which we can round off to 0.29, so the total pressure is 0.29 atm.